Hello, my name is Sam Buchanan.
And I'm Jonathan Seiler.
We were both tasked with creating the twin oscillating steam engine.
As you can see, this is the parts list we were given for this project. We were each tasked to make 10 of these parts that will come together to make this assembly over here on the right, and we will show you in this presentation how these parts come together and how that they were made.
To start it off, this is the base. It's made of wood. I created a rectangular drawing on the bottom, and I padded it up all the way through thickness. Then I used the chamfer function to chamfer 3 of the sides, as you can see, all the way around. I ended up using the hole command to place the first pilot hole, and then I use a rectangular pattern to create the distance between the two and the instance of the second one.
This is the base frame. I used a sketch to define the back plate here, and then used pad to define the thickness. The hole command was then used to determine all these holes on the center of the part. I then created a sketch on the bottom of the part here to create this little flange here, and then the hole command was then again used to create these holes down here, and then I used the fillet command at the end to create all of these fillets all around the edges.
This is the big end. I used a simple rectangular shape on the back, and then I created a pad, the thickness, and then I used edge fillet all the way around the outside to create the radius that you can see. And then I used the hole command to create this center hole on the front face, and another one to create the hole on the top that goes through the top portion of this.
This is the crank bearing. This is where I used a sketch and a shaft to create the bulk of the part. The sketch started with the center line going all the way through, up and around the part itself, and then the shaft command was used to make the entire part. The hole command was used at the end to create this hole right here going down into the part, and it only goes into the center here, does not go all the way through.
This is the crank plate. It was a little bit more of a difficult part. I used a simple rectangle again all the way around the back, padded it out the thickness, and then I had to use 3 different radiuses all the way around to create this curvature that you see here. And then I used the hole command to place each one of these holes, this one starting, because the distances given were from that hole, from here all the way up, the height and width.
This is the crankshaft, another part where I used the sketch and shaft commands. I started off with the sketch down the center of this shaft, going up and then defining the geometry, and then using the shaft command to create the part. I used the hole command at the end to determine this hole at the very end.
This is the crank pin. Used a similar process. I used the center line all the way through, up, and then all the way around to create the general geometry, and then use the shaft command to rotate it around 360.
This is the second crank pin. Again, like the others, I started off with a sketch and I went around and defined the part, and then I used the shaft tool to create the revolution, and then there was a fillet used at the end to create the rounded off back.
This is the cylinder. It's located on the back of the assembly. It is where the piston is held. To create this part, I used the center line here and a basic sketch of the outside geometry, and then I used the hole command to create this hole on the outside with an edge distance given in the parts list.
This is a cylinder block, one of the more complicated parts of mine. I started with this top face up here, and I sketched it out and defined all of the radii and geometry. I then patted it down, and then I used the pocket command here to create these 2 flanges on the back here, and then finally the hole command was used to create these 2 holes on the top and the bottom. This top hole here goes through this thick top flange, and this bottom hole here does not go through the bottom flange.
This is the cylinder block stud. It was created the same way the cylinder was. I used the center line that goes all the way through the middle, and then the general geometry to create the shape of the outside, and then I used the shaft command to rotate it all the way around.
This is the flywheel, another complicated part I had to take on. I started with a sketch of this whole outside circle here and then patted it down to create the general geometry of the part. I used the pocket command to create the pocket here, and it is equal on both sides. The hole command was then used to create this center hole and this side hole here. The center hole is a regular hole, and this side hole is actually an M3 hole. It was defined using the catalog. I used the circular pattern to create these 4 holes in the center of the part here, and they are equidistant, and I use the chamfer here to create a 45-degree chamfer on both sides.
This is the piston. It was created using similar process. I created the general outside shape with the inclusion of the indentation out here, and then I used the shaft command to rotate it all the way around. I had to use a pocket right in the middle with mirrored extension on both sides to create this flat edge, and then I used the hole command on the bottom so the piston stem can be inserted.
This is the piston stem. I started off with a sketch defining the basic structure of the piston stem itself, and then I used the rib command here to define the geometry. I started with a circle down here, and then that defined the diameter of the stem, and then it extended it down and created the part.
This is a stiffening plate, one of my more difficult parts. I created the general geometry again with the triangle in the back, and then padded it out the thickness. I ended up having to get a little bit of a radius here because the part that it's attached to has a curvature. You can't really see it in this drawing, but it does at the very bottom. That's where I use the pocket command. And then I had to use the hole command to place each one of these holes. And the only geometry given for the distance here was the distance from the bottom through the center line that goes all the way through each one. So I had to use a little bit of geometry to figure out where those go.
This is the second stiffening plate. I started off with a sketch of this front side, and again, you can't really see it in this picture, but there is a radius here at the top because it attaches to a circular shaft, and then I patted it down the rest of the way.
This is the spring. It was arguably my hardest part because I had to use generative shape design with the helix function. Starting, I had to use a point fixed about the origin with the radius here, and then I used the total distance of the springs divided by the instances to get the distance here, and then I used the number of instances to get the total length, and then I used a circle fixed about the point here and the rib tool to make the entire geometry of this.
This is the top block, a relatively simple part. I started off with the front face sketch here, and then I patted it down. I used the hole command to make these two top justified holes, and they do go all the way through, and then the edge fillet was used to round off the edges.
This is the wood screw. It ties the base end to the base. No sketch was given on the parts sheet, so we used the catalog to determine the M4 size of the screw because of the base ends diameters of the holes.
And this is the nut. It's another catalog part. We used an M3 nut as defined in the parts list and attached it to the back of the assembly to hold on the spring. In conclusion, this is our final assembly. As you can see, all the parts come together quite nicely. On the right here, you can see half of our parts list. On the next slide, you will see how all the parts fit together and the other part of our parts list.
As you can see, this is the exploded view. It shows you exactly how these parts fit together as previously shown in the assembly. This is the last half of the parts list, and it shows you how they all connect via the X, the Y, and the Z axes. This is the end of our presentation.
Thank you.